Limits at infinity, L'Hopital's rule. Here we want to evaluate the limit as x approaches infinity of natural log x over x to the fourth using L'Hopital's rule. So first we want to make sure that if we think about evaluating this, we end up with an indeterminate form. So natural log x as x approaches infinity is infinity, and x to the fourth as x approaches infinity is infinity. So this is the infinity over infinity indeterminate form. So it is eligible for L'Hopital's rule. So L'Hopital's rule says we could take the derivative of the top and the bottom separately and evaluate that new limit. So this is the limit as x approaches infinity of the derivative of natural log x is 1 over x. The derivative of x to the fourth is 4x cubed. So we want to simplify this. Basically, we can rewrite this as the limit as x approaches infinity of 1 over 4x to the fourth. So basically, this x drops down to the denominator, and we have 1 over 4x to the fourth. And so now we have a constant on the top over 4x to the fourth. So as the x values are being substituted into the denominator is getting bigger, while the top is staying constant, so that overall fraction is going to go to 0. Now let's evaluate the limit as x approaches infinity of the quantity x minus 2 times e to the negative x. If I think about what's happening to each part of this product, the first part, x minus 2, as x approaches infinity, that's going to infinity. So we're going to have is infinity times, okay, now e to the negative x. What's going to happen to that part of the product when I substitute in numbers heading towards infinity? So let's plug in something like 100. Let's do this off to the side. So if I have e to the negative 100, because again, there's a negative there. So if I plug in positive 100, we're going to have e to the negative 100. Well, that's 1 over e to the 100. And that is a really small number overall. So 1 over a really big number. E to the 100 is huge. So this is getting really small. It's going to 0. So I have infinity times 0. And infinity times 0 is indeterminate. And so I can't move forward with this. I have to think about another thing to do to evaluate this limit. And what I'm going to do is rewrite it as a quotient. So I'm going to rewrite this as the limit as x approaches infinity of x minus 2 over e to the positive x. So much like when we did it with a number, negative 100, we brought it to the bottom, that negative exponent, if I bring that to the bottom, it's going to be a positive x. And so now I still have an indeterminate form. I still have infinity over infinity. So e to the x as x approaches infinity is infinity. So it is a candidate for L'Hopital's rule. So we will go ahead and take the derivative of the top and bottom separately. The derivative of the top is 1. Derivative of e to the x is e to the x. But now I have a constant over this function that's getting really big towards positive infinity. So a constant over a really big number is really small. So this is going to 0.